A raindrop hitting a lake makes a circular ripple. If the radius, in inches, grows as a function of time in minutes according to r of t equals 25 the square root of t plus 2, find the area of the ripple as a function of time, and then find the area of the ripple at t equals 2. Okay, so we basically have two questions here. They first want us to find the area of the ripple as a function of time, and then we can plug in the specific time that they're searching for. Now, the only way that this equation is, or this question is going to work is if you guys knew what the equation for the area of a circle is. And I say circle because they say that it's a circular ripple. So they gave you context as to what area you should have done, all right? So circular means circle. Area of a circle is always pi r squared. So that's basically the first thing that I'm going to write out, all right? So we're going to say area equals pi r squared. We need to find the area. Okay, well, here's the general formula. But we need to find the area of the ripple as a function of time. Now, they gave us this nice equation here, r of t, and I'll put it over here, r of t equals 25 the square root of t plus 2. R stands for radius, and t stands for time. So here is a time value. And if you plug in for this formula, you can get out a radius. But look here. Oh, radius. These two correspond with each other by a radius, right? So the first thing that we're going to have to do is we're going to have to relate these two equations together. We have to write an equation for the area of the circular ripple in terms of time. So what I'm going to say is, we'll give this more context. I will just say that A of r equals pi r squared. Now I'm making it a function. And as you can see here, the letters match on both sides. So now I can tie these two functions together. Here is my function number 1, and here's my function number 2. I'm going to make a composite function. Now, what do you think, guys? Remember, composite functions, and I'll write it over here, it's usually f of g of x, right? We have always a inner function, and then we always have an outer function. The outer function is always done last. That's usually what you're solving for. The inner function has to be done first. So, tricky part coming up. We have two functions, 1 and 2. Which one is done first and which one is done last? Remember, the last one is usually the one that you're looking for. So if they're saying find the area, that's what we're looking for. So this needs to be, the area function needs to be the outer function, and the radius function has to be the inner function. Okay, so now I can say A of r of t. As you can see here, this is the inner function, and the A is the outer function. So number 2 is in the middle, and number 1 is on the outside. And we can, figure what this is. That's basically what we need to solve for. So now we're going to do the rules that we have been doing for the whole playlist of working from inner to outer. So I'm just going to put our steps over here. 1, r of t is just 25 square root of t plus 2. Now I'm going to plug in A for, remember, the answer to your inner function is always what you plug in for your outer function. So it would be 25 square root of t plus 2. And now let's see. We go back to our outer function. Our outer function was pi r squared. And any time that you see an r value, you're going to plug in for this. So let's see. This is now going to be pi. What was r? Oh, this is our new variable. So I'm going to say that it's 25 square root of t plus 2 squared, because I have to go back to my outer function squared. And this is my overall composite function, the a of r of t. And this is the answer to the first part. Pi 25 square root t plus 2 squared. Now, since we have this function, all we got to do is just plug it in. I think the second part, they just said, find the area of the ripple at t equals 2. So what are we going to plug in, guys? Oh, a 2 for t. Let me just first pull this up here. I'm going to do this part over here. So I'm going to say a of r of t equals pi 25 square root of t plus 2 squared. Now they're saying that t has to equal 2. So I'm just going to plug it in. So this would be equal to pi 25, the square root of 2 plus 2, all squared. So let's work on that. This would be equal to pi 25. The square root of 2 plus 2 is 4. The square root of 4 is 2, right? And 25 times 2, this is squared, right? So 25 times 2 is 50. 50 squared is the same thing as 50 times 50. It is not 50 times 2. So this would be equal to, 50 times 50 is pi 2500. And that is the answer. I don't know if you have to multiply it by pi, but if you have to, let's just say 2500 times pi, we get roughly 7,854. Units here, let's see, they say inches, so this has to be inches squared. Remember, area is always in a unit of something squared. So this would be your actual area. And if I bring this all down, this would be, a of r of t. And there you go. So either they don't want you to simplify and you get 2500 times pi, or if you do the actual math, this is what you would get. All right, guys? But that's it. This one was pretty easy. The hardest part was just figuring out your two functions. But then you just mesh them together like we've been doing for the whole entire playlist. And you guys are good to go. All right? So give this video a like if it helped you, or a thumbs up. Subscribe if you want more math videos coming your way. We've got physics videos too at the moment, but tons more videos in the future. I'll see you guys all in the next lesson. I hope you guys have a great day. Bye-bye.